Welcome back, grade 12 learners, teachers, and any other interested party. This is one part, very interesting in physical sciences, which involves the organic molecules. The part is physical properties. I just drawn one recent paper. We can start with 2.5. Normally this question is question number 3. But let's just this question of interest, which is 2.5, is just saying compound A undergoes complete combustion according to the following balance equation. We are given that methane plus oxygen forms carbon dioxide and water is a typical combustion, balanced. And now they say during the combustion, 2.75 kilogram of carbon dioxide is formed. That is a product. Calculate the mass of methane needed for this reaction. This is a typical stoichiometric calculation. Therefore, what we need to do is that because we are given the product, we need to determine the reactant. Now, there are two methods in this case. We can use any one of them. I'll try to show you both so that at least we are well equipped in this section, especially when balance equation is used. And this is the equation that is given, carbon dioxide plus 2 water molecule. Now if we are given a 2.75 kilogram, remember in chemistry we don't use kilograms, we normally use grams. Therefore this will be 2750 grams. That is the best one that you're going to use in this case. Now there are two methods. The quickest one is what you call mass calculation. So if you deal with mass calculation, you go to the balance equation to say, if you look at the mass of methane, which is CH4, is to the mass of carbon dioxide. In this balance equation, methane is 18 grams, 12 plus 4, and then produces 44, 12 plus 32, 44 grams of carbon dioxide. But we are not producing 44 this time around. We are producing 2,750 grams. How many grams of methane will do that? If you do your cross multiplication, you'll find that X will be 18 multiplied by 2,750 divided by 44. Therefore, your final answer will give you somewhere around 1,000. In this case, 1,000 grams. That will be the case. Fine. That's the first method. The second method, this is option 1. Option number 2, you can go for mole stuff. Now we calculate the number of moles of carbon dioxide with 2,750 grams. Therefore, the number of mole of carbon dioxide will be given mass over the molar mass, which is your 2,750 divided by 44. Therefore, your answer will get 62.5 mole. That's the first one. Now, once you find the mole of carbon dioxide in a balance equation, you can relate it to that one. We know that the number of mole of methane, in this case, is equals to number of mole of carbon dioxide. The two are in the ratio 1:1. Therefore, this will be 62.5 mole. That is the methane one. Now we don't need mole of methane, we need the mass. Then now we go back to the same formula to say mass of methane, CH4, will be the same as number of mole multiplied by the molar mass, which will give us 62.5 multiplied by 18. Then this one will give us that it's not 18, sorry, supposed to be 16, not 18. I don't know, where did I get this 18, because it's 12 plus 4 is 16. Pardon for that one. 16, supposed to be 16, this one, 16, and then you get your 1,000 grams. That's how you can solve this problem. Very easy stoichiometric, simple stoichiometric calculation. You get 5 marks for doing that. Let's move on and come to the physical properties. Now, there's a question on physical properties here. It's question number 3 in a normal question paper. Remember, as I said, therefore, now you are given this to say the boiling points of 4 organic compounds at a specific pressure are compared. Before you can even go to question, you can just analyze. Normally, there are 3 things that you need to do: homologous series, and then your variables, and also the intermolecular forces. You can see that A is an alkane, B is an alkane, C is an alkane. If you look at them, they all have got 5 carbon atoms. Then is your C5H12. Therefore, the 3 A, B, C are chain isomers. Fine. And then they all have got the London forces within their molecules, and also what you should know in this case, they're chain isomers, they're in alkanes, and then fine. Then D and E, if you look at D and E, D is a aldehyde, therefore it consists of dipole forces, and then E is an acid which will have hydrogen bond. So fine. Without even like answering the question, you can see that anyway, since hydrogen bond in the E are stronger than this one, then we'll be having the boiling point of E being higher than 103. Fine. Let's go to the first question. They say to us, now with the information in the graph, in the table, define the term boiling point. Remember, we have got these 3 physical properties, one of them being boiling point. So boiling point is a temperature. So temperature at which the vapor pressure, vapor pressure of a liquid. You can just say vapor pressure without of a liquid is fine. Of a liquid is equal to the atmospheric pressure or the pressure of the surrounding. That's for 2 marks. Now 3.2.1, they say to us here, consider compound A to C. So from A to C, typical trend. Fully explain the trend in boiling points from compound A to C. The easiest way of answering this question, there are many ways. Easiest way of answering this question will just use the trend. Using the trend is very easy. Just tell the examiner to say, I'm moving from A to C. Therefore, from A to C, remember A has got the longest chain length compared to the rest of them. Therefore, from A to C, the chain length decreases. Chain length decreases. And then again from A to C, the strength of intermolecular forces Remember the recent recommendation now, they say you must not write IMF. You must not be lazy. You must write it in full. Decreases. The last point here, or the third point will be, now once the strength of intermolecular force decreases, therefore the energy required to overcome the intermolecular forces decreases. And then the fourth mark, because it's 4 marks, therefore boiling point decreases as well. So if it's 3 marks, you'll just do up to energy. That's the case. That's a typical trend. But normally you will say there are so many ways of doing this one. Remember, you can opt, instead of A to C and say C to A, you write the opposite. Or you can just go for extremes to say, if you go for extreme, remember you will say now A is either you start with A. A has got the longest chain length, and A has got the strongest intermolecular forces, and A requires the most energy to overcome the intermolecular forces. Therefore, A has got the highest boiling point. That's when you start from A and going for extremes. If you start from C, you write the opposite. That's how you can do it. But the longest one will be now to say, I start with A, but I just say A has got the stronger longer chain length than both B and C, or A has got the longer chain length than B, B has got the longer chain length than C. That's the very long one. But anyway, I don't think any of us will be using that one. So most of that we are used to this section. Okay, fine. The 3.2.2 will be now saying which compound will have highest vapor pressure. Once you reach this section, remember vapor pressure is very close to boiling point. Therefore, the higher the vapor pressure, the lower the boiling point. I mean that you just go to the table and check which one has got the lowest boiling point. Again, this one from A to C, it will be C. Then we just tell the examiner now C. Fine. You can even expect the explanation. Yes, explanation. If we are doing maths, we'll say the reason is given. But we are doing physical science, we'll just say therefore it has got this one lowest boiling point. Lowest boiling point. Don't say lower boiling point, please. Lowest boiling point, because here is the question of English. We are comparing 3 compounds, so you can't use the word lower. So it has to be the lowest. So fine. Now in 3.3, they are asking us to say compound D and E are compared. Is the boiling point of compared? Is the boiling point of E greater than, smaller than, or equal to that of C, or to 103? So we know that E will have the higher boiling point. Fine. It will be greater than. Write the word greater than. You're just choosing according to the word is given. Fully explain. Okay, fine. We are comparing 2 compounds from different homologous series. Then first will be about the type of intermolecular forces in each. Then we'll just tell the examiner now to say, you can start with D or start with E. Fine. No logical order is preferred. D has, because it's an aldehyde, has dipole forces. Dipole forces within within its molecules. And then while you can just say E has hydrogen bonding, hydrogen bonds. Fine. And then point number 3 will be now comparing the strength of intermolecular forces. You can start with D. Fine. D has weaker intermolecular forces. Than E. Or someone can just say London dipole forces are weaker than hydrogen bonds. That one also would be acceptable. And then here it will be a question of or, because there are only 3 points available. It's either you mention the strength or you mention the energy. Then we'll just say if I start with D following the same order, there's no, it doesn't say when you start with D in this point number 3 you are forced to start with D here. No problem. If you start with D, you can start with E. If you start with E here, you can start with D here. So each and every point is marked independently. So D requires, molecules of D requires less energy to overcome the intermolecular forces. Than E. If you start with E will require more energy to overcome, or molecules of E, if you want to be academic, molecules of E requires more energy to overcome the intermolecular forces than molecules of D. That's how you get all the 4 marks here. I hope it's understood. We'll come to the last 2 questions. In this case, they say to us, is the comparison in 3.3 fair? We look at the 2 compounds. We are in 3.4. If you look at the 2 compounds, pentanal will be your C. If you compare it, C5H10O, and then butanoic acid will be C4H8O2. If you look at their molecular mass, let's check whether is it comparable. 12 times 5 is 60 plus 10, 70 plus 16 is around 86 grams. And then this one, 12 times 4 is 48. And then plus 8 is 56. And then plus 32. Therefore, it's somewhere around 88. So the 2 are comparable, yes. Therefore, comparable masses here. Then our answer will say yes. The reason, hopefully they will say explain, yes, they've got comparable masses. Comparable masses. If you want to add more, you can say and only one independent variable. Is changed. Which one is changed between the 2? Then we are changing here the functional group or the homologous series. Only one independent variable or only homologous series is changed, or only functional group is changed. So only one independent variable is changed. That's how you can reason for this one. So that was then the reason is yes is 3.4. The reason is 3.5. I think that's how this is. So be careful on this one of fair comparison. Remember, in a fair comparison, you must only change one independent variable. If you change more than 1, therefore it's no longer fair. So that's the bottom line in this case. Hopefully with these explanations, it's getting clearer and clearer, and it's preparing well for any similar questions in relation with these organic compounds. And hopefully you're enjoying it. From this one, we'll be moving to our reactions, which is your chemical properties of our organic compounds. Don't forget to subscribe, and so that any upload, you will be the first one to get the notification, so that there's a new video, you can watch it and then get equipped with the physical science information. Knowledge is power. Good luck in all your exams and tests, and pre-final and final and trial exams, whatever. So any assessment, good luck for you. Thanks a lot. Until next session. Bye.